So you understand the sine function. Unit oscillates, starts at 0, and comes back to 0. And if I asked you, you could probably tell me the sine of pi over 4 pretty easily, using the unit circle that you learned back in kindergarten. But here's a question. Could you tell me the sine of 0.7? You can't, can you? I see you reaching for your calculator. If this were no calculator test, you'd probably fail. But what if I told you there was a better way? Using calculus. Back in the early 1700s, English mathematician Brooke Taylor was posed with the same dilemma. He created the Taylor series. What's that, you ask? Well, it's a way to represent a function using a bunch of smaller terms and adding them together. Let's take a sine function, for example. This is a function that you are very familiar with. However, unless the x value is a multiple of pi over 4 or pi over 6, you probably have no idea what the y value is. So to approximate this, we can start by running a tangent line through the point 0, 0. This follows the function for a little while, at least until the sine function curves back. So it's not a very good approximation, but it is trying. So essentially, to get this tangent line, we just took a derivative. But if you want a better approximation, we can take even more derivatives and use them to make a Taylor series. Let's try taking 3. And to make it simple, here's a formula to represent how these derivatives make up a Taylor series. So the general term for a function approximated at x equals a is the sum from n equals 0 to infinity of the nth derivative of f of a times x minus a to the n over n factorial. The third order Taylor approximation of sine of x at x equals a is the sine of a plus the cosine of a times x minus a minus the sine of a times x minus a squared over 2 factorial minus the cosine of a times x minus a cubed over 3 factorial. This pattern goes on and on. However, this one is the third order because the last term includes the third derivative of sine of x. So now we can visualize our function with our various forms of approximation. Here's the sine function by itself, and a simple line matching its slope at x equals 0. And here's our third order Taylor series, which we can simplify to x minus x cubed over 6. For values close to the center of approximation, this is much easier to calculate, even with our original value of 0.7. See, the sine of 0.7 is 0.644, but if we plug 0.7 into x minus x cubed over 6, we get 0.643, and that is pretty close. And there you have it. That's a Taylor approximation. So try this one on your own. The fourth order Taylor approximation of cosine x centered around x equals 0. Pause the video and play it when you found the answer. And the answer is 1 minus x squared over 2 plus x to the 4th over 24. This has been Calc Fun with Thomas. See you next time.